One of the most important features of CSS is being able to define how a website or app is presented on different media or output devices, like a desktop screen, a mobile device, or a certain viewport width or height. Media queries allow us to do just that by applying CSS to elements dynamically based on conditions that test certain features of the output device. We use logical expressions to test for certain things like viewport width, resolution, or a device width and height to tailor our content to a wide range of devices without having to change any of the actual content because it's controlled entirely within the CSS. With just a few media queries, we can create subtle or drastic changes in the layout or appearance of a website. That's why they're most commonly used in responsive web design to enhance the browsing experience of websites and apps on multiple devices and viewport sizes. So let's get started with media queries by first taking a look at common media features for screen-based design and ways we can apply them to a document.
Okay, so let's start by taking a look at a few good examples of media queries being used on some popular websites. So I'm just going to go to the site mediaquery.es or media queries, which showcases sites with good use of media queries. So for example, I'll go ahead and click on the nextweb.com here. And we can see that the page loads with a 3-column layout. And as the viewport gets narrower, it changes. So it's now a 2-column layout. And finally, when the viewport or screen is much smaller, the layout is a lot different than the full screen version. It's more optimized for smaller screens or mobile devices. So this is all done with media queries. At every breakpoint we see, the site's style sheet is serving a different set of styles to the page in order to make these layout changes happen. So let's find out how this is done. Now, in the past, it was common practice to use a separate style sheet for printing web pages by specifying a media attribute and the value print. Those print-specific styles were then served to the page only when they're called up to print. So media queries takes this idea to a whole new level because they allow us to target CSS styles based on a number of device features. Now, there are a few ways we can include media queries in our page, but first we'll use the most common method, which is adding the media at rules directly in our CSS. So our HTML file consists of a wrap div with some content. Here we see a heading 1 and a couple of paragraphs, and the style sheet has a few simple base styles, and we can see what it's looking like in the browser. Nothing too exciting. So let's take a look at what makes up a media query. A media query is simply a style block containing one or various logical expressions that are either true or false. So to create our first media query in our commented section here, we will type at media, followed by a set of parentheses and a set of curly braces. Now the at media rule here is what specifies the media type we want to target. There are several recognized media types we can use so that we're able to create CSS and serve it specifically to any of these media types here. For example, handheld, print, and screen, even some for braille and projection. If we do not specify a media type, the all type will be implied, which applies to all devices. So because we want the styles to affect the browser, we'll go ahead and specify the screen media type. So back in our style sheet, after the at media rule, we will go ahead and type screen. So next, we'll need to follow screen with the keyword and. The and keyword is what's called a logical operator, and we'll use it here to combine the screen media type with the media feature that will go inside the set of parentheses here. We'll get more in depth with logical operators later, but first we'll need to pass an expression in the parentheses using a media feature. The expression is what checks for the true or false conditions of the media features we define. Some of the media features we can use are width, height, color. We can also check for things like the orientation, resolution, and a few other things. Now, the width and height features can also be prefixed with the word min or max so that we're able to test for a min or max width and height. We'll get to a lot of these throughout this deep dive. So first, we'll go ahead and start with max width. So back in our style.css file, in between the parentheses, we will add max width. So we added the media feature. Next, we'll need to add a value. We specify the value for a media feature after a colon, just like we would with a CSS property. So for the value, I will go ahead and make this 768 pixels. So this will query the max width of the display area, which in our case here is the browser viewport. Here we set it as a pixel-based value, but we can also make this a percentage value, an M value, or any length unit. Now, one important thing to keep in mind is that these logical expressions should not have a semicolon after the value. Otherwise, the expression will be ignored. It's a common mistake to make because we're so used to adding a semicolon after every CSS property value. So make sure that we keep those out of the expressions. So we have our media query ready to go. Next, we'll need to add selectors inside of it, and those selectors will always be associated with these conditions we set in the query. So we can really see how this media query will affect our page. We'll go ahead and use the body element as our selector. And inside of it, we will add a background property, and we'll give it a hex value of a tomato shade of red. And we will give it a color property with the value white. So let's recap what our media query here is doing. So if the media type is a screen, and if the browser viewport is 768 pixels wide or less, remember max width is anything equal to or less than the width defined. So if the width is no wider than 768 pixels, the background and text colors of the body will change to the new color values we defined. So let's take a look at this in the browser. We'll go ahead and save, and then refresh. And now when we resize the viewport, we can see how the corresponding style rules are applied whenever the browser width is resized. So if you can see right here, when the viewport hits that 768 pixel width, the colors change and they remain that way as the browser gets narrower. But once we're at anything wider than 769 pixels, it changes back to the initial page styles. So back in our CSS, let's go ahead and add another media query. We'll again type @media, followed by screen, and then a set of parentheses, and a set of curly braces. Now, this one will change the background to blue once the viewport is 480 pixels wide or less. So to do that, we will type max width 480 pixels. Then we'll again select the body element and give it a background property. And finally, we will need to apply our hex value of a shade of blue. Okay, so let's go ahead and save this and take a look at it in the browser. We'll refresh it. Once the viewport is equal to or below 480 pixels, the background color turns blue. Now, notice how the font color remains white at the smaller size, even though we did not specify it in the new media query. The color value still applies because the conditions we've set in this top media query here are still true. The viewport width is still less than 768 pixels, So unless we overwrite it with a new property, like we did here with background, the value will remain as white, unless it's above 768 pixels. So we only need to include the differences we need to define inside the media query, not any of the other properties, as those will still carry through. But say we want the background color to be red and the text color to be white, only at a certain range of viewport sizes. Well, the neat thing is that we can add or combine expressions if we need to in order to get more specific. So, for example, we'll follow our first expression here with the AND operator. Then we'll create a new expression using the min width feature and the value 481 pixels. So the AND operator here is combining these two expressions. The values only apply between the maxed width of 768 and the min width of 481. So when the viewport is between 481 pixels and 768 pixels. So we'll take a look at this in the browser by first saving it. And I'll refresh it. So let's start resizing this viewport. So now we can see that the text no longer maintains the white font color when the viewport is less than 481 pixels, because we've instructed the browser to apply the styles only when the browser is between 768 and 481 pixels. Then it sort of turns them off and applies the changes defined in the media query for viewport widths no wider than 480 pixels. Like I mentioned earlier, there are other ways to include media queries in a document. For example, we can create separate style sheets, then link them to the HTML document with the link tag, the same way we'd link any style sheet. We'll just need to make sure that they're linked below the main style sheets. So I've created two separate style sheets containing the same styles we just added to our media queries, which I'll go ahead and comment out so we can see how this works. One of the style sheets is named wider.css, so we'll go ahead and include that there. And the second one is called narrow.css. We'll then need to define the media queries inline using the media attribute. So I'll just go ahead and paste these in because these are the same ones we created earlier directly in our CSS. So with these linked media queries, we're telling the browser, apply this style sheet only to a device that has a screen and only if the browser window is between 768 and 481 pixels. And the same goes for the second one, but only when the browser is 480 pixels wide or less. So we'll save this. And when we take a look at it in the browser, we can see how it works the same as when we had our media queries directly in the CSS. Now, the downside to this method is that we need to include multiple link tags, one for each query. So we'd be creating more requests to the server, which, depending on how many we include, can significantly affect our site performance. Another drawback is that style sheets with media queries attached this way will still download, even if the media queries return false. They just won't apply to anything. The good thing about the method we used earlier is that when media queries are in one CSS file, they're only loaded by the browser when their conditions are true. So we'll go ahead and remove these for now. In addition to linking to style sheets with a media query, we can also add them as part of an import directive in our style sheet. So this works similar to using the import rule for importing style sheets. We'll go ahead and paste these in. So the syntax is pretty similar to what we previously did in the link tag. The media queries are still the same. And they will work the same way by importing the style sheets and applying the styles to the devices if these conditions are true. So let's go ahead and save this and view it in the browser. And we can see how it works the same way. But as we've learned in previous lessons, add imports can be quite expensive performance-wise because each one is also a separate server request. So it shares some of the downsides of using that link tag method. We'll continue this deep dive using the media query blocks directly in our CSS like we did earlier. So I'll just go ahead and uncomment this. Now, finally, we will add one more media query to prevent our wrap div here from spanning too wide when the viewport width is increased beyond a certain width. This way, the text will maintain a readable line length, because right now it's a little too long. So in our CSS, below our media query here, go ahead and add media screen and parentheses and a set of curly braces. So for our expression, we will use the min width feature and a value of 1000 pixels. So we'll need to adjust the wrap div once it's above 1000 pixels. So we'll select wrap and give it a width property, and let's make it 700 pixels. So it will be fixed at 700 pixels once it reaches a minimum width of 1000 pixels. So let's save this. So in the browser, I'll go ahead and hit refresh, and we can see how everything works the same, but when the viewport is greater than or equal to 1000 pixels, the width of the wrap div remains fixed at 700 pixels.